Look at the heavy, spiked shell scuttling across the sand, and you are staring directly into deep time. Biologically speaking, the horseshoe crab has remained largely unchanged for hundreds of millions of years. Long before the first massive reptiles walked the earth, these exact animals were already patrolling the ocean floor. While apex predators rose to absolute global dominance and then vanished, the horseshoe crab quietly endured. The physical record leaves no room for doubt. The anatomy we see on modern beaches perfectly matches the imprints locked in ancient stone. It is nature's ultimate survivor, a biological tank that successfully navigated every single planetary extinction event history threw at it. But that heavy shell is only the first line of defense. To understand how they have lasted this long, we have to look past the armor at a second, more specialized layer of protection hidden in their veins. Horseshoe crabs bleed a striking, intensely bright blue liquid. It is a surreal aesthetic that looks like it was engineered in a sci-fi movie. This is the central paradox of the species. The unique immune system that helped this animal weather millions of years of microbial threats is now the very thing driving it toward extinction. Human dependency on this bizarre blue liquid has turned history's most resilient animal into a remarkably fragile modern victim. To understand why we need it, we have to look closely at how this fluid behaves in a laboratory setting. The blood contains singular immunocells that operate as a highly sensitive biological alarm system, instantly detecting foreign bacteria. The moment a pathogen is identified, the cells trigger a rapid clotting response. They expand and build an impenetrable gel barrier, trapping and neutralizing the threat immediately. This is a highly efficient prehistoric engine specifically adapted to identify and isolate contamination. Modern medicine relies on this exact threat detection mechanism to ensure that human pharmaceuticals, intravenous drugs, and medical equipment are completely free of dangerous bacteria. Today, the extract created from horseshoe crab blood is the mandatory safety test for manufacturing over 100 different vaccines worldwide. Because there is no universally approved synthetic alternative that matches its sensitivity, testing pharmaceutical batches without these specific immunocells is virtually impossible. The structural integrity of the global public health system currently depends entirely on the harvested bodily fluids of a bottom-dwelling sea creature. That massive scale of medical reliance comes with a heavy physical toll. Every year, commercial biomedical operations capture hundreds of thousands of wild crabs to drain a portion of their blood. While the crabs are released afterward, the mortality rate from the bleeding process is significant. The relentless, growing demand for sterile vaccines forces severe overharvesting year after year. This chart shows compounding variables threatening the species. On one axis, the steep upward trajectory of human harvesting quotas. On the other, a sharp decline in available coastal acreage, meaning the exact regions where they breed are being destroyed. Fighting a simultaneous war against medical overharvesting and habitat loss is mathematically unsustainable for the population. Due to intense pressures, the ancient horseshoe crab is now officially listed as vulnerable to extinction. If this population collapses, the first impact hits the coastline. Entire migratory bird populations and marine ecosystems rely on crab eggs as a primary food source. Their disappearance would trigger enormous cascading damage to coastal habitats. The second impact hits us. Losing our primary method for screening medical contamination would create a catastrophic roadblock for human science and global pharmaceutical production. A moment of wonder. Our ability to safely produce the medicines we need is tied directly to the health of the sand where these animals lay their eggs. It proves that no matter how advanced human science becomes, our survival still depends entirely on nature.